All right, I'm going to talk about solving rational equations. This will be my first of a few videos on solving rational equations. So here we go. We're going to solve this equation, and before we're done, we want to check our solutions because we might have some extraneous. So looking at this problem, we have 6 divided by x minus 1 equals 9 divided by x plus 1. Now, here's what I tell students here. I said, well, what's the most difficult part about this problem? The most difficult part is the actual fractions. Most students don't want to deal with fractions. So let's make that our goal. Let's see if we can eliminate these fractions, and then let's see if we can solve with what's left over from that. So again, this is very, very interesting. We're going to be looking at eliminating these fractions. So what's going to happen is this can become very similar, but it's not the same as adding and subtracting. So it's going to be very, very similar, but not the same. So make sure you distinguish between the two. With adding and subtracting, we want common denominators, which means we want fractions. With solving, we're going to try and eliminate the fraction part here. So here's what we're going to do. First thing I want to do is, if we're going similar to adding and subtracting, we always focus on a common denominator. We're going to do the same thing here. So I want to make sure my denominators are factored. So over here I have just an x minus 1, so that's going to stay the same. And on the right I have an x plus 1. That is going to stay the same. So nothing is changing there. So what I'm going to do is let's come up with that common denominator, which, by the way, that's the same thing as a least common multiple. Those are going to work hand in hand. Let's figure out what the common denominator here is. Now this is the part that's very similar to adding and subtracting. So I need an x minus 1, so there's x minus 1. I also need an x plus 1, so there's my x plus 1. So that is my common denominator, least common multiple. So that is as far as the adding and subtracting similarity goes. This is where we start going different on how this is a solving problem, not adding and subtracting. So remember, the most difficult part of these problems is the fraction part. So here's what we're going to do. We're going to take this least common multiple, which is our common denominator, and we're going to take the entire thing and we're going to multiply both sides. Now when I multiply both sides, all I'm going to do is I'm going to multiply the top. So over here I'm going to write x minus 1 and x plus 1, and that is being multiplied to the top. I'm going to do the same thing over here. I'm going to multiply the top by x minus 1 and x plus 1. Notice how I'm not also multiplying the bottom. I'm just multiplying the top only. If you do it on one side of the equal sign, you got to do it to the other. Now that, again, I told you that's where all the adding and subtracting similarities, that's where it ends. So we're only multiplying the top. Here's why that's helpful to you. So this is all multiplied up top, and this is all multiplied up top. Well, if you look, on top I have an x minus 1, and on bottom I have an x minus 1. So those are common factors on top and on bottom. So those cross out. So what you're left with is you have a 6 times an x plus 1. So I'm going to distribute that through. 6 times x is 6x. 6 times 1 is 6. Same thing happens on the other side. So I have all these pieces up top of the numerator and this one piece in the denominator. Notice I have an x plus 1 on bottom and an x plus 1 on top. So when those pieces are on the same top and bottom, I have a 9 and an x minus 1. So I'm going to distribute that. So 9 times x is 9x. 9 times negative 1 is negative 9. So I went from a problem that had fractions to using the least common multiple, common denominator situation. I've gone from an Algebra 2 problem all the way back to an Algebra 1 basic problem. So I have 6x plus 6 equals 9x minus 9. So the only thing left to do from here is solve this for x. Because remember, when we're solving, we're trying to get a variable all alone. So what I would do to solve this, I'm going to go a little bit quicker through this since this is and should be review. I'm going to move this 6x to the other side. So that would give me a 6 equals 3x minus 9. And then I want to get this x all by itself. So I got my x's together, but I want to get it by itself. So I'm going to add 9. So that gives me 15 equals 3x. And then to get x completely alone, we're going to divide by 3, and I get 5 equals x. Now, before I move on, I want to check and make sure this works. So I don't just want to assume this works. So we're going to take this x equals 5 and let's plug it back into the original problem. So we always need to check. Super, super important because we might have extraneous solutions. So what that's going to look like is I'm going to have 6 over a 5 minus 1 equals 9 over 5 plus 1. So I just need to simplify each side to make sure the left is equal to the right. So that is 6 over 4, and that is 9 over 6. Let's reduce this fraction on the left side. 6 over 4, what can we divide both the top and the bottom by? Can divide each by 2, so that gives me 3 over 2. On the right side, I have 9 over 6. Look what I can divide both the top and the bottom by. Divide each by 3, and I get 3 over 2. So as you can see, we get 3 over 2 equals 3 over 2. Those are the same. That means my answer of x equals 5 worked, and that is solving rational equations 1.